reaction of mechanisms. In this video, I will cover unimolecular nucleophilic substitution and bimolecular nucleophilic substitution. But before we can start that, I would like you to tell me what is an electrophile and what is a nucleophile. Just bear in mind and know these terms, because if we don't, we might struggle in the reactions, especially substitution and eliminations. So another reminder for that, I can tell you an electrophile is electron poor species, which means they love electrons and therefore they are positively charged. And examples can be NH4 plus, CH4 plus, hydrogen plus, which doesn't mean anything to us because hydrogen has got 1 electron, and if you lose that electrons, it becomes to 0, which in reality doesn't make sense, but there is, just bear in mind. And so in summary, what's an electrophile? An electrophile is an electron diffusion species and will react by accepting electrons in order to obtain a full valence shell. This may be positively charged species, and therefore we can see NH4+. However, in some rare case, you may see neutral. For example, we may see BF3, which is neutral, but is mostly positively charged. So therefore, making reactions by getting electrons from other molecules, this loves to get electrons. And an electrophile therefore is absolutely opposite side. This is very rich in species and therefore is negatively charged. For example, it can be HO minus, it can be NH3 with a lone pair, hydrogen, and oxygen, which is a OH2, and a chlorine with a minus side, negative side. So in general, a nucleophile, they are very rich in electrons. They want to share the electrons, and they have electrons available for donation to electron diffusion centers. This may be negatively charged and in some cases neutral, but with lone pair. If it is neutral, there is lone pair for oxygen and nitrogen, so they are mainly negatively charged. So we know that electrophile is electron poor, nucleophile electron rich. So now we can start and find out more about substitution. Initially, I would like to cover unimolecular nucleophilic substitution. Unimolecular means for one, stands for uni, it means one. Nucleophilic, we already know, is N, and S for substitution. So we can say this is SN1. This is known as SN1. Imagine we have got a tetrahedral species like this, and therefore the first thing happens in SN1, that is the ligand, which is a leaving group, this LG, leaves. So when it leaves, there is going to be a leaving trigonal planar flat 120 degrees molecule files, so we can write that as we can draw this ZYX. So because the leaving group left, we have got a positive charge here. And the main thing about SN1 you need to keep in mind is we always forming a trigonal planar, which is (120 degrees). And therefore, a nucleophile, which there is here, this has the two possible sides to attack. For example, this can attack either from the top or this can attack from the bottom. Therefore, we have racemization, which means that proceeding with two-product racemization. If you look at the stereochemistry, in the other video I've explained what is stereochemistry and how we can find RNAs and go to understand how the molecules they're moving in the air in the 3D molecules that are moving, and you can show it and express it there. So for example, if this shape is R, racemizing that shape proceeding to have a 50% chance and product. So if it's R, we either have R and S on the product. We have R and we have S because there are two chances for nucleophile files to attack. 50% from the bottom, 50% from the top. So we have, this leads to have two products for SN1. Just bear in mind for SN1. So the initial rate equals, so the rate equals constant to substrate. So therefore in the products we always have both R and S. That's the main point of SN1. So we will shortly form the product. If these products attacks from the top, so we gain so the nucleophilics comes here. So we get X, Y, Z, and because we're getting two products, we may also have so these are the two products we have from SN1. So another short summary. Unimolecular nucleophilic substitution, first leaving group leaves, and there is no double bond involved with substitution. So we will never have a double bond. There is no resonance as well. Leaving groups leaves. So what happened? A carbon cation intermediate forms. When the carbon cation forms, the nucleophilic attacks. It can have two sides, above and below. If it attacks from the above, we get this. If it attacks from the below, we get this. So it doesn't matter. Above and below, there are two sides, the possible attacks, the possibilities, so we can have, and that's the main difference between SN1 and SN2. And racemization form, which is the two products we get from there. So if it's not clear, I can you can comment and I can explain it more. But I believe that's very straightforward. And enantiomers can form because there are enantiomers. Yeah, there are each of them. We can say an enantiomer. So briefly, first summary. I can show you here in the summary we have first leaving group leave, then carbon cation intermediate forms, then nucleophilic attacks from the two sides, and racemization form. So now looking at bimolecular nucleophilic substitution, which is slightly different, but not really different. It's slightly different. So for bimolecular nucleophilic, bi means two, which is 2SN2. So our spontaneous reactions. This is not like fast living group. This is not such a thing. But this happens spontaneously. This happens at one stage. So to understand that, so the first I will introduce the rate equal constant to nucleophile and times by substrate. Reactivity is dependent of the substitutions around the halides. So this means the tertiary halides, they are more reactive than secondary and primary. So the strong nucleophiles, they require very strong nucleophiles. Two species, they are involved at the same time. So imagine, so I will just initially explain that more so you understand why we, so you understand, you'll be more familiar with the terms. So imagine we have got the same tetrahedral. A tetrahedral in reality life, we already know that is 109 degrees 0.5. So imagine we have got a tetrahedral. We never have a tetrahedral like this because this is not a tetrahedral. Tetrahedral means there are something like this. I don't know if you can see that or no. Yeah. So therefore, in each of these, we get 109.5 degrees away. So I will show you again. It's going to be something like this. Now if you can see that perfectly. All right, yeah. So therefore, to attack, imagine again, to attack something, we have got this here on the top. Yeah, so let's see. We have got this. There is too much atoms that are here, so we cannot attack at the same side. It can have from the opposite side. Imagine, so we have got something here. So the attack should happen from the opposite side. So this leaving group can leave, and there's a substitution happens from the attacking group can come, and then the leaving group has to leave. So I can show you on the paper again more, so that you can understand. So we have got a nucleophile here. The nucleophile attack the carbon, and the leaving group leave. So this means that there is 180 degrees between the nucleophile which attack and the leaving group. Because if the leaving groups, but on the paper exams, teachers really do not really concern and bothered with the where to attack. But I just explained that so you have an idea on your top of your head, so you can understand why we attack the carbon from there, why we don't attack from here or anywhere else, because these leaving groups is blocking this way, so there is not enough space for nucleophile to get through from here to the carbon. But this side is a planar. When the nucleophile attacks from the back of this molecule tetrahedral, so it can easily get to the carbon. So another just an example to show you. This is like this, but this is planar. It's like this, yeah. But this is on the other side. Just imagine, guys. Yeah. So if the nucleophiles can attack, it cannot attack from this side because it's already blocked. It has to go from the opposite side. But when it attacks, at one stage, simultaneously, they are both facing each other until the leaving group leave. So that is the difference between the SN1. So there in this way stage, we can form a transition state where we get I show that with dots, so you can see the leaving group and the nucleophile. At some stage they are together, and the transition size, please put that for the exams, is very important. And I can say this is X, this is Y, and this is Z. So in some point when the nucleophile attack the carbon before the leaving group leaves, they face each other, which can be shown in the transition state. This is the transition state, so I just write it down here for you. So this is, we have got, because carbon has hold up to 4 bonds, but this carbon is not really happy, so this wants to leave something as soon as it can, so come back to the normal state when carbon has 4. So when the leaving group leaves, so this comes now to make nucleophile bonded so we get only one product. This is not same as SN2 where we got 2 products. We have only one product. One product. So this means we get from 100% to 100%. 100% starting point, 100% is the product. There's nothing lost. Obviously there are, but not really significant amount, so we cannot consider that. So the more important is to understand there is one product for SN2, and it happens simultaneously once the nucleophile attack. So is also there is not involved with double bond, and alkenes is not involved with the substitution. So in summary, we can say leaving groups leave and nucleophile attack simultaneously. It means is very, very fast and quick at the same time. So they are happening at one stage very quickly. So please bear in mind, this happens very fast. Transition state occurs, show all the species involved, which are the leaving group and nucleophiles plus other three species, and one product form which is inverted from the starting. Please bear in mind again, if we are starting from R, we are getting S, and if we're starting from S, we are getting R. Please watch the stereochemistry videos I have put. If you don't understand, please find out books from the chemistry books. From what I recommend is YouTube videos, because they are really helpful and they are short, so you can understand this and all. So from 100% we get to 100%. If you have got 100% R, we get 100% to S, and if you have got 100% S starting materials, we get 100% for products. And also, just to cover that again, bimolecular nucleophilic, it means SN2 is known as SN2, so the rate is equal to constant, and nucleophile to substrate, so it's happening mainly simultaneously, and we get one product at the end. Hope that is very clear and there's no any doubt, but if there is, please comment, and I'm really happy to get back to you. Or please also know this process is reversible. This means reversible, yeah. Just need some practice and exercise, and in the next video I am happy to go through eliminations E1 and E2, and thank you for watching us.